Okay, let's get started with our discussion today. This time we'll be doing a lab run-through of experiment 17, properties of solutions. Again, here is the location of the properties of solution lab, and I'd also like to direct your attention to a few additional pieces of information. So first, here's the properties of solutions page. We also have the pre-lab lecture as well as the report submission page. So here's where we will be submitting our final report. And here is the pre-lab lecture section, which covers a lot of the theory behind this lab. I would encourage you, as always, to watch the pre-lab lecture, to view the experiment page, and to read the pre-lab recommended reading and the lab introduction found in the lab manual. For reference, here is experiment 17 in the lab manual. Experiment 17, properties of solutions. We're going to be going through this lab together, and we'll be discussing and interpreting some of the videos and data provided as part of this lab. So first and foremost, if we go to the experiment page, we have some recommended reading. So we want to read through the introduction section. The lab page has a detailed introduction discussing the theory behind this experiment. I would encourage you to read the introduction section. We then have our experimental procedure section, which we'll come back to in a moment. In the main lab manual, we have the lab goals. We have an introduction section discussing the theory, which I would encourage you to read. And then we have the experimental procedure. This is what we're going to be following through today. Additionally, further down below the experiment procedure, we have the pre-lab questions, which you will complete, as well as the report sheet. The report sheet has the data tables that we'll be filling in and the questions that we will be answering as part of today. I've taken the liberty of transferring the report sheet onto my drawing program, so that way we can share these annotations digitally and you can see how, as we collect observations in this lab, we include them in our report sheets. So with that said, first things first, the first thing we're going to do is we are going to, one moment, we are going to go through the experimental procedure and follow through it step by step. So let's go to the experiment procedure and let's read what we're doing. So the first part are the identification tests. These include the silver nitrate test, the iodine test, also known as the starch iodine test, and Benedict's reagent, which is a test for glucose. Silver nitrate is a test for chloride or other halide anions. So we have some videos. We're going to view these chemical tests, and we're going to record our observations. Of note, the chloride test and starch test are pretty much instantaneous, while the Benedict's test for glucose requires heating in order to elicit a chemical reaction, which results in a color change. And we'll see that dramatic color change in a moment. So here is the video. So let's expand this video. So first we have the silver nitrate test. So if we add it to a sodium chloride solution, as we can see, we're starting to observe the generation of a white solid precipitate. That's the silver chloride precipitate. So this is what a positive silver nitrate test looks like. As you can see, the chloride ions have reacted with the silver, and we get a white precipitate. Here is the iodine test performed on the starch solution. Iodine reacts dramatically with starch to make the blue-colored starch-iodine complex. As you can notice, the starch and iodine react almost instantaneously to make the dark blue colored starch-iodine complex. So this is what a positive starch iodine test looks like. So if you test a sample with iodine and it changes into this color, it's highly likely that it contains starch. This will be important for later. Finally, we have the Benedict's test. Benedict's reagent is a sort of light blue color, and upon heating, it reacts with glucose to generate, as a byproduct, an orange color, which is likely the result of generating some copper ions in solution or some solid copper in solution. So, as noted, the Benedict's test and Benedict's reagent test requires heating. So as we heat the sample containing glucose and Benedict's reagent, we will begin to see a color change. As time passes, as we can see, the color has changed quite dramatically from a blue to an orange-brown color. Wonderful. I would encourage you to watch these videos as well with the sound on. I've turned the sound off because I'm providing my own discussion and narration for many of these procedures as part of this lab walkthrough, but I would encourage you, if you watch these videos independently, for you to watch them with the sound on if possible. Okay, so let's now fill in the identification test section. For the chloride test, we observe a white solid precipitate. For the starch test, we observe a blue-black color change. And for the glucose test, we observe a color change from blue to orange-brown upon heating. Okay, so now that we have that out of the way, we're going to begin our overview and we're going to begin discussing the osmosis and dialysis procedure. Just to help you visualize what's happening here, we load our reagents into the dialysis bag and we allow some time to pass. Over time, certain ions and compounds will be able to pass through the dialysis bag membrane, while other compounds will not. We are going to monitor and observe over time what happens in terms of the composition and the types of soluble material found inside the dialysis bag and outside the dialysis bag. And from this information, we can figure out what ions or other soluble or otherwise insoluble species can pass through the dialysis bag and which substances cannot pass through the dialysis bag. To this end, we're going to be testing the water at 0 min and 30 minutes. And then we're also going to test inside the dialysis bag at the end of this experiment, at the end of this time duration. Based on the chemical test results, we're going to determine what compounds stayed in the bag and which compounds were able to pass through the dialysis bag membrane. With that context out of the way, let's now read the protocol. So they're going to set up a dialysis bag containing starch, glucose, and sodium chloride. We're going to immerse the dialysis bag in deionized water. At the 0 minute test, we're going to pour out some of the solution from outside the dialysis bag and see what we observe in terms of the 3 chemical tests we performed. We're then going to allow 30 minutes to pass and we're going to test the water outside the dialysis bag using the same set of chemical tests. Finally, we're going to open the dialysis bag, pour it out, and test inside the dialysis bag using these 3 chemical tests. So that's what we're doing. Let's now watch some videos. So In this first part, we're looking at the preparation of a solution. That solution was loaded into the dialysis bag. As you can see, that's the dialysis bag that's being filled. And the dialysis bag is now being immersed in deionized water. Now, just intuitively for a moment, if we test at time equals 0 minutes and it's deionized water, which theoretically has nothing in it, we shouldn't see positive results for the time equals 0 sample. It's just deionized water. This just provides us a baseline. Now, why do we test the water? To make sure it actually is fully deionized. Here's the time equals 0 test. So this is the water from outside the dialysis bag tested immediately. As you can see, the silver nitrate test, nothing happens, which is good. That's to be expected. If you are performing this lab in person, sometimes you can see some positive results for the silver nitrate just because diffusion through the dialysis bag is actually quite fast. So if you're not sampling the water immediately, you may see some positive results here. As we can see for the iodine test, it is negative. We don't see that dark blue starch iodine complex. So we can conclude that we don't have any chloride ions, nor do we have any starch molecules present outside the dialysis bag at time equals 0. Finally, Benedict's solution will be employed. And remember, you have to heat this solution in order to make a definitive assignment as to whether it's a positive or negative test result. To this end, the sample is moved over to heating. As you can see, after extended heating, there is no color change. So let's tabulate our initial results. So at the 0 minute, we observe no precipitate. So that tells us there is no chloride present. For the starch test, we see no color change. And thus there is no starch present. For the glucose test, we see no color change. Thus, there is no glucose present at the 0 minute mark. Okay, let's now continue on. Okay, so we tested at time equals 0. 30 minutes later now, we are going to pour the water from outside the dialysis bag and test the water outside the dialysis bag. So this is our time equals 30-minute test sample. So the water is partitioned. Additionally, the water inside the dialysis bag is poured into a separate container. And the water inside the dialysis bag will also be tested. Okay, so we're now moving on to test. This is the silver nitrate test. And as you can see, we have a positive silver nitrate test. Moving on to the iodine test. We do not see a change for the iodine test. Again, the sample that's being tested in this batch of tests is the water outside the dialysis bag after 30 minutes. So we have a positive silver nitrate test and a negative iodine test. Finally, we're testing the solution outside the dialysis bag at 30 minutes with Benedict's reagent. The Benedict's reagent solution is subject to heating. And even though there's a little bit of color change, not much has really happened. Maybe a little bit of glucose got out, but not much. Okay, we're now going to be looking at the dialysis bag inside the dialysis bag at the end of the experiment. So this is the silver nitrate test for inside the dialysis bag. And let's write down some of our observations here. So for outside the dialysis bag, we observed a precipitate at 30 minutes, and yes, there's chloride present. For the starch test, we see no change, so there's no starch. And for glucose, we see a minor change. So yes, there's a small amount of glucose, but not very much. Inside the dialysis bag, we see that the silver nitrate test yields a precipitate, and thus chloride is present. Let's see what happens in terms of the starch test. Here is the starch iodine test for inside the dialysis bag. We see the dramatic dark blue color indicative of a positive starch iodine test. And finally, this is the Benedict's test result, which we can see the bright orange-brown color indicative of a positive result, indicating that glucose, starch, and chloride are present inside the dialysis bag. So let's write that down. For the starch test, we observe a blue-black color change, which tells us, yes, starch is present inside the bag, and we observe an orange-brown color when we use the glucose test with Benedict's reagent, which tells us, yes, glucose is present inside the dialysis bag. So as we can see, some compounds stay in the dialysis bag while other compounds are able to pass through and escape the dialysis bag. This is how dialysis functions. It is a membrane that is permeable to a select group of ions or other soluble compounds. Okay, you'll answer the questions independently. And we're going to talk a little bit about the filtration section. So let's go to the procedure for filtration and let's watch the video for that. So in this case, they're going to take the mixture of glucose, sodium chloride, and starch from part B, and we're going to add a small amount of powdered charcoal and mix. We're then going to pass the whole thing through a filter. From here, we're going to describe the appearance of any substance on the filter paper, what substance is present on the filter paper, and then we're going to test the filtrate, which is the liquid that passes through the filter using the chloride, starch, and glucose test. Okay, so let's watch the video for that. Okay, so here is the filtration run through. To produce corn. So I'm turning off the audio in this case. Right now they're preparing the filter paper. The filter paper has been loaded into a filter funnel and wet with water to ensure that the filter paper is secured onto the filter funnel. From here, they're passing a solution containing the charcoal as well as the solution of chloride, glucose, and starch. As you can notice, the charcoal does not dissolve in the water and sits as almost a suspension. We're going to allow this entire solution to filter through our filter paper, and then we're going to test the filtrate, which is the liquid that passes through the filter. As we can notice, the charcoal is not passing through the filter, which makes sense. The charcoal is not soluble in water, and the particle size is sufficiently large that it can't pass through the filter. Okay, so after several minutes have passed, we now have the filtrate liquid, which can be tested. After several more minutes, as you can see, the majority of the charcoal has been trapped on top of our filter, while most of the liquid has passed through the filter paper and ended up in the receiving beaker. This would indicate that the charcoal is likely a suspension. It's not soluble in water. Okay, that filtrate liquid that we've obtained, we're now going to be testing. So here's the silver nitrate test for the filtrate liquid. As we can see, there's an almost immediate reaction to generate the silver chloride white precipitate, which indicates a positive test result for chloride. Looking now at the iodine test, we're going to be testing the solution for starch using the iodine test. And again, we see a pretty much immediate color change indicative of a positive starch iodine test result. This tells us that there is starch present in the solution that passed through the filter. Finally, we'll be testing the solution for glucose using Benedict's solution. And after walking it over for heating, and allowing some time to pass, we see the characteristic orange-brown color indicative of a positive test result for glucose. Let's tabulate our observations now. For the chloride test, we observe a white precipitate, and thus this tells us that chloride is present. For the starch test, we observe a blue-black color, which tells us that starch is present. And for the glucose test, we see an orange-brown color, which tells us that glucose is present. In terms of the appearance of the filter paper, we can see it has a black/dark color, and the substance present on the filter paper is the charcoal. In terms of identifying each substance as a solution, colloid, or suspension, I will leave that for you to assign based on the experimental results and observations we've collected together. Of course, you will answer all of the remaining lab questions, and then you will submit the entirety of your report sheets to the Experiment 17 report submission page. This concludes our lab run-through for Experiment 17 in CHEM 100.